All right, section 6.7, we start talking about transformations we can perform on similar figures and how we can create similar figures by doing these transformations. So how do you perform transformations to create similar figures? The first one we're going to talk about is a dilation. A dilation is a transformation that either enlarges or shrinks a figure to create a similar figure. Shrinks, another word we'll use is reduces. The center of dilation. In a dilation, a figure is enlarged or reduced with respect to a common point. So every point's going to move, get bigger or smaller around a common point. And just to note that all the dilations in this lesson are in the coordinate plane, and each center of dilation is the origin. The scale factor is k, and that tells us how much bigger the shape is getting, bigger or smaller. So if k is less than 1, and I should say it's also got to be greater than 0. So if k is between 1 and 0, it's a reduction. It's going to get smaller. And if k is bigger than 1, then it's going to be an enlargement. It's going to get bigger. So like 2. 2 is bigger than 1. So if k equals 2, the shape will be twice as big. Let's say k is 1/2. 1/2 is between 0 and 1. So 1/2 would make it smaller, so it's going to be half the size or half as big. Right, and the coordinate notation is going to look like this. You take your xy coordinate and you multiply it by k. And again, if k is between 0 and 1, it's a reduction. If k is greater than 1, it's going to be an enlargement. Right, so example 1. They tell us, draw a dilation of quadrilateral ABCD with vertices A, B, C, and D given. Use a scale factor of 1/2. So if we were to graph ABCD, A is at 2, 0. B is at 6, -4. Whoops, down here. C is at 8, 2. And D is at 6, 4. So we have A, B, C, and D. We also can put that over here and write it out. A is at 2, 0. B is at 6, -4. C is at 8, 2. And D is at 6, +4. So k is 1/2. So that means we're going to multiply everything by 1/2. So this is kx and ky. So everything is times 1/2. So 1/2 of 2 is 1, and 1/2 of 0 is 0. 1/2 of 6 is 3, 1/2 of -4 is -2. 1/2 of 8 is 4, 1/2 of 2 is 1. 1/2 of 6 is 3, 1/2 of 4 is 2. All right, so A is at 1, 0. A prime is at 1, 0, I should say. B prime is at 1, 2, 3, -2. C prime is 1, 2, 3, 4, +1. And D prime is at 3, +2. So you can see that red shape is shrunk up to half the size of the blue shape. So the scale factor is 1/2, which made it smaller. And actually, if you need more time, you can just pause here and make sure you got that down. Going on to example 2, it says a triangle has the vertices of 2, -1, 4, -1, and 4, 2. The image of ABC after a dilation with scale factor of 2 is DEF. So sketch ABC and DEF. So ABC is at 2, -1, 4, -1, and 4, 2. So A, B, C. And now we want to sketch DEF with a scale factor of 2. So what that means is you take A and you multiply it by 2 to get D. So times 2 would be 4, negative 2. If we have B, which was 4, negative 1, you multiply it by 2 to get E, which would be 8, negative 2. Right, and C is 4, 2. You multiply it by 2 to get F, which would be 8, 4. So if we graph that, 1, 2, 3, 4, negative 2 would be D. 8, negative 2 would be E. And 8, 4 would be F. So verify that the two triangles are similar. To verify that they are similar, we would see that this side, the blue side DE, is 4. And the side FE is 1, 2, 3, 4, 5, 6. This side is 2 and this side is 3. And then we can see that both, I'll make them green, both green angles are right angles. So if we do 4 over 2, which would equal 2 over 1, and then we do the scale factor of 6 over 3, which would also be 2 over 1, and then angle B is congruent to angle E. So this would be side, angle, side similarity. So that's how we verify it. It's side, angle, side similarity because of the sides are proportional, and then there's one angle that's the same. Right, then example 3 says you are making your own photo magnets. Your photo is 8 inches by 10 inches. The image on the magnet is 2.8 inches by 3.5 inches. What is the scale factor of reduction? Well, to find that, we just take the sides here. 10 inches and then 3.5 inches. And we'll take the scale factor of reduction would be you take your image over the pre-image. So what we have is 3.5. What it was 10. So if you reduce that, 3.5 over 10, we can make the top into a 1 by dividing by 3.5, which would be 1, and then you do 10 divided by 3.5, which would give you 2.9 or 2.85. So the scale factor of reduction would be 1 over 2.85. So for every 2.85 inches the picture was, the magnet's going to only be 1 inch as big. Okay, if we take a look at checkpoint 1, it says that a triangle has the vertices of BCD. Find the coordinates of LMN so that triangle LMN is a dilation of BCD with a scale factor of 4. And it says to sketch both triangles. So let's start with B, C, and D. B is -1, -1. C is 0, 1. And D is 1, 0. Okay, to get LMN, we have to multiply by 4. So L would be at -4, -4. M would be at 0, 4. And N would be at 4, 0. So if we sketch this, BCD, B is -1, -1. C is 0, 1. And D is 1, 0. B, C, D. LMN is -4, 1, 2, 3, 4, -4, 1, 2, 3, 4. m is at 0, 4, 0, 1, 2, 3, 4. Then n is at 4, 0, 1, 2, 3, 4. So we can see the blue one is 4 times as big as the red one, triangle BCD. In example 3, what is the scale factor of reduction if your original photo was 4 inches by 5 inches? So if the original photo was 4 by 5, and remember the new one was 2.5 by 8.5. So again, we would set up a fraction, which would be the bigger number from the new image is 3.5, and the bigger number from our original photo was 5. So the reduction would be 3.5 over 5, which end up being, we can leave it as that. If you want to find the actual number, it will be 3.5 divided by 5, which is 0.7. So it'll be 0.7 or 7/10 the size. Right, example 4. You want to create a quadrilateral JKLM that is similar to quadrilateral PQRS. What are the coordinates of M? Okay, this is a tricky one. So J and P match up. So here's J, and here's P. The coordinates for P are 0, 3. And the coordinates for J are 0, 6. So to go from 0, 3 to 0, 6, what is happening? We are multiplying by 2. So the scale factor is 2. K equals 2. Right, and also 6 over 3. You could find that by doing 6 divided by 3 is 2. So if we're looking at trying to find M, M matches up with S. So S is right here. S is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So S is at 5, 5. So we would take 5, 5 times 2, and we would get 10, 10. So 10, 10 would be point M, because M matched up with S and we have to double it, so it'd be at 10, 10. So it'd be something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 10 would be like way out here. So this shape right here, that red shape would be what you end up with when you double everything. Okay, and then the last checkpoint, you want to create a quadrilateral QRST that is similar to quadrilateral WXYZ. What are the coordinates of T? So if you look, we have Q and W right here. So W is at 0, 2. And Q matches up with W. Q is at 0, 5. So what you're doing to get Q from W is it's 5 over 2 is our scale factor. 5 over 2. So the scale factor is 5 over 2. And we want to find out what the coordinates of T are. T matches up with Z. So find the coordinates of Z. Z is right here. Z is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So Z is at 4, 6. So if you want to find the coordinates of T, T is going to be 5 over 2 times 4 and 5 over 2 times 6. Okay, that's what this is going to be. So T, 5 over 2 times 4 is 5. And 5 over 2 times 6 is... Actually, I was wrong. This is not 5. This would be 10. and 5 over 2 times 6 is 15. So the coordinates for t are 10, 15. And again, we found that by getting the scale factor and then multiplying each coordinate by 5 over 2. And that's how we find similar figures by doing transformations. We're doing dilations.